So welcome to Zero to Lab, the pathway to CCIE. So this course is actually designed in a way that you get all the important information, the theory that you need to know. You get confidence and also ample time to make sure that you practice all the important topics and become comfortable with it, along with the support throughout the course. So what exactly is the structure? Let's talk about it. So first of all, this course is for CCI Enterprise Infrastructure exam. So there are many different branches in CCI or many different streams you can go through. Like for example, you can do CCI routing and switching, which is now called Enterprise Infrastructure. You can also do CCI Security, CCI Wireless Collaboration, which is voice and video. There is also CCDE, which is for the designing. So this course is actually designed for routing and switching, CCI, which is CCI Enterprise Infrastructure exam. So this exam, if you want to pursue this exam, there are two things that you need to understand. First thing is the qualification for the exam to be able to book the lab. So that is called the qualification exam or ANCOR 350-401 exam. So this is an MCQ exam, multiple choice question exam, and this is also one of the core exam for CCNP certification. So earlier, what used to happen, there were separate exams for CCNP like route, switch, and T-shoot, and then you had a CCI qual exam, dedicated CCI qual exam that you need to pass multiple choice question exam to be able to book the lab, the actual CCI lab exam. But now they have actually made it much simpler, I would say, because while you are preparing for your CCNP, and in CCNP you need to pass two exams. One is the core and one of the concentration exams. So if you do your core exam preparation for CCNP, then you are also becoming qualified to book the lab exam, right, for the CCI lab. So once you pass this exam, then you can book the lab exam, which is the CCI Enterprise Infrastructure, and the latest version is version 1.1, and that's what we are covering. We will cover all the information into this version. And in case if there is any update during our class, we are definitely going to include those updates as well. So you will get the latest information and the latest training for this particular part of the exam. Just a second. So talking about the lab exam, you will see that this is a 8-hour hands-on based exam. Means you will have to fly to the location where you have the exam testing facility, and you need to configure different protocols, which is called the multi-protocol lab, and there will be a topology that you need to configure it on. But that is also divided into two parts. This exam, first part is the design part, where it will be similar to the written exams like multiple choice question exams, and it is going to be 3 hours. It will have multiple choice questions, drag and drop questions, and maybe like a tabular questions, but no configuration. So to prepare for this part, we will see that when we go through the fundamentals of different protocols, the theory part that we are going to cover, that is going to make sure that you will be prepared for the design part. Because if your fundamentals are strong, you understand how the different protocols work, you will see that this part will become pretty easy, pretty straightforward. As this part covers mostly similar to what you see into the CCNP and core exam, like multiple choice questions and the important details of routing protocols, switching protocols, and SD-WAN and programmability part. But then second part is the configuration, deploy, operate, and optimize part. So in this one, you get 5 hours and you will get a topology, a new topology. And on this topology, you will have to start configuring protocols. So you will start building up from switching, then routing, then advanced services or configurations like multicast, MPLS, VPN technologies, quality of service, any IP services. So that all will be configured in this part. But don't worry, you don't need to do it from the scratch. Means there will be some IP addressing already configured. Some of the protocol configuration will already be there. You just need to add the configuration or fix the configuration to make it working. So it's not that you will have to do everything from scratch, starting from IP addressing and all. It will have some configuration already there. So it has three major sections: routing and switching, SDN, and programmability. And out of these three, the biggest part is the routing switching. In the routing and switching part, you start from switching, where you have to configure VLAN and trunking, Ether channel, maybe VTP, also a spanning tree protocol. So all the switching configuration will be there. Then you will build the routing. So in the routing, you will have protocols, uh, interior gateway protocols, EIGRP, OSPF, and exterior gateway protocol will be BGP, and any other configuration that you have in routing switching, like IP version 6 or multicasting, DMVPN, MPLS, those things, anything like HSR, PVR, PGLBP, which is the uh, redundancy protocols, all this configuration will go into the routing switching part. So we are going to cover all these topics, and I'll explain you exactly what is the syllabus or the curriculum for CCIE that we are going to cover. But this is the biggest part of the configuration part. And then comes the second section, which is the software-defined networking. So in software-defined networking, they have two different branches. If you are doing it for the campus or the LAN side, it is called SDA, software-defined access. And if you are configuring it for the WAN side, it is called SD-WAN. So software-defined simply means that you are decoupling the control plane and the data plane. So your devices will be forwarding the packets based on the policies they have received from a central control plane unit, which we call the controller. So decoupling your brain of routing and switching or the policy making, and you placing it into a single place called the controller, that is called software defined networking, so that you can decide all the policies and push them from a central location. And you can do it either on the LAN side or on the WAN side. That's why there are two different parts, SDA and SD-WAN. So we are going to cover this also in depth with all the logic and configuration. And then comes the programmability. So programmability means using automation to make sure that your configuration can be pushed to devices, and you can either retrieve the information from the devices or change the information on the devices. So here we are going to see some interesting aspect as well. For example, EEM, embedded event management, where you can use the in-house scripting of Cisco routers and switches to response to different events. If something happens, you can actually take some certain series of events. For example, if your router is configured with BGP, and it is one of the very important edge routers with all the necessary and important BGP configuration, so you don't want anybody to accidentally delete BGP on this router. So if somebody tries to type the command no router BGP on this router, not only that command should be ignored, but the incident should be logged, and email should be sent to the administrator, and also there should be a warning message shown on the device that the person who was trying to do this has been logged, that information has been logged along with the timestamp. So all these things you can do as an action or as a response to the event that just happened. And this is just one example. You can actually do it for any important interface. If somebody tries to shut down the interface, it should immediately be unshut and the event should be logged. So all these kind of things you can do with the EEM, with the in-house scripting. But also what makes it interesting is that we can do the same thing from outside. So we can start sending some API calls to the routers and switches, the application programming interface calls. And these calls are basically the instructions, either to retrieve some information from the device or to change some information on the device. So we are going to understand in detail what different data formats are used for that. Like we can use XML, we can use JSON format, or we can use YAML format. So different formats are there. Also, when you're sending the instructions, what language are you using? Because you cannot just send something in simple English sentences, right? You need to use a structure which is understood by the device as well. So there is something called data model, which is used by all the devices, Yang data models. We are going to understand Yang data models as well. And then what protocol is used to carry out your instructions all the way to the devices. So we can use either the netconf protocol or restconf protocol. So we will understand those as well. And we will see examples of retrieving or changing configuration of a router from your PC by using netconf and restconf protocols. And then the final thing is, how can we automate these things? Of course, I can manually send instructions to the router using netconf or restconf, but I can also create Python scripts where when you execute the script, it is going to send the instructions on behalf of you and change the configuration or retrieve the configuration from the devices. So all these things we are going to learn, including the introduction to Python language. If you have never done it before, don't worry, we'll cover it from the scratch, from the basics. And as a matter of fact, although it is a CCI level course, that means we are expecting you to know the basics at least on the CCNA level, if not CCNP. But still, whenever I start a new topic, I'm always going to start it from the scratch. And we are going to learn it all the way to the CCI level. For example, if you are going to start spanning tree protocol, or if you are going to understand what is dynamic multi-point VPN, or how does multicasting work, we will start it from zero all the way to the level that you need for CCIE. And I always try to explain things in or structure things in three different questions. What is the technology we are talking about? Why do we need it? And then how to configure it. So when the what and why is clear, your how will become much easier. Instead of directly starting is showing you how to configure MPLS, if I first tell you what is MPLS and what problem is it solving, why do we need MPLS in this world? If that is clear, then it will be much easier for you to get on the logic and understand, okay, that's why we need it. And now we will talk about how to configure it. And remember, throughout this course duration, always have the mindset of learning. So when I'm explaining you something, of course, naturally you will be learning few things, and if you already know them, you will be bridging the gaps. But when I send you the lab to configure things, don't take it as a test. Don't try to think, okay, I need to remember everything I learned from the session, and I need to configure it right now from my memory. That's not the point. The objective of the lab is to re-strengthen all the logics or all the concepts that we learn into the live session. So in the live session, I will be also doing the lab in front of you. So not only you learn the topic, but also you see me doing it and configuring it, so you understand it better. And then you do it during the week when we don't have the session. And that's why I also send you the solution file along with the question, not because I'm trying to test you, so that you can always go back to the solution file whenever you get stuck or you forget something. Because remember, when the what and why is clear, the how part will take some time. It will take some practice. So always remember that whenever you get stuck, don't get demotivated. Just think, oh, that's a great opportunity. That means I'm going to check the solution file, how to do it, because I'm stuck right now. And then I will learn something. Okay, this is how it is done. So that is something new I learned. So always have the mindset of learning. You need a paradigm shift here throughout this course. And of course, when it comes to practicing at the end to before going for the exam, that time you can start testing yourself, but not before that, right? So you can see that the exam has three major sections, and you will see that devices are already partially pre-configured. As I mentioned already, that you will not need to configure everything from scratch. You just need to fix few things. For example, if they're asking you configure OSPF in the headquarters, you will see OSPF is already configured in the headquarters, but there are some certain routers which are not forming neighborship, or some commands are missing or deliberately misconfigured. So you might need to just troubleshoot a little bit and fix the issue and add the configuration that is needed. As a matter of fact, before they used to have a different structure for the exam. And I'm talking about version CCI version before it was called enterprise infrastructure, when it used to be called CCI routing and switching. That time they had 2 hours of troubleshooting troubleshooting part, and then 6 hours of configuration part. So in the troubleshooting part, you had 10 tickets or 10 troubleshooting questions on a different topology. Since they scrapped it, and now you only have the configuration, so they do include troubleshooting here and there a little bit within the configurations. Like if they're asking you to configure OSPF in headquarters, there might be some deliberately wrong configuration that you will need to fix. So again, troubleshooting is something that you will become very good if your fundamentals are strong. Like if the OSPF neighborship is not coming up, you need to know what are the process, what is the step of neighborship, what is the finite state machine that we use for forming the OSPF neighborship. So a hello message is exchanged, and there are some certain parameters which must match, like the network must match, if authentication is configured, that must match, area ID must match, timers must match, MTU must match. So when you know that what needs to be same between two routers to become neighbor, you can quickly check those things if they are same or not, and that way you will be able to find out what is the issue, why the neighborship is not coming up. So troubleshooting completely depends on your fundamental knowledge, and we are going to make sure that you become fundamentally very strong, so that troubleshooting becomes second nature when it comes to the configuration and fixing the issues. With the exam, they will give you a PDF that you will open, and there will be instructions. So that is called the multi-protocol lab, and you will need to configure the devices as per the instruction, right? And step by step, you will build upon layer 2 and then layer 3, then VPN services, any extra services like multicasting or QoS. Then you will configure SDN, and then you will configure programmability, which will be the last part. So that will be the order of operation when it comes to the lab exam. So that actually brings us to the syllabus of it. So let me show you from the official Cisco website, the Cisco CCIE Enterprise Infrastructure version 1.1. What is the syllabus of this course or the curriculum of the exam? So you can see that the network infrastructure is the first part, which is 30% of the exam weight, and where it starts from layer 2. You need to know how exactly the switches work. What is the logic used in the layer 2 switches? What is the MAC address table, error disable recovery concept, and what is the maximum transmission unit in a layer 2 frame? Some protocols like CDP, LLDP, and UDLD, VLAN and trunking, Ether channel, and spanning tree protocol. So you can see that the switching part is very lean. It's not a lot of different switching topics they cover. Earlier, they used to have a lot of other things also, like Flex VPN also, and QNQ trunking. They also used to have layer 2 WAN protocols like triple P and multi-link triple P and all these things, PAP and chip authentication. So they have cut out all these things, and now they're concentrating on the core switching topics. VLAN, trunking, Ether channel, VTP, and spanning tree protocol. As a matter of fact, VTP is also not there, but it's a very lightweight protocol. We can understand this while we are going through this. So you will see the biggest topic in switching part would be spanning tree protocol. And we are definitely going to have multiple sessions to understand it in depth. And of course, everything else. Again, anything we start, I'm going to assume that you have no idea about this, and we will take it from there. So if you really don't have any idea about this, you will get the idea. If you already know about this, you will bridge the gaps that you have, or if something you might have forgotten, that you will basically revision those things, right? And again, we will go through the structure of what is the technology we are talking about, why do we need this, and then of course how to configure it. Then comes the routing part. So in routing, we are going to understand different routing protocols like OSPF, EIGRP, BGP, and what is the concept of static routing, and also the importance of administrative distance when you are electing the best route, or you are choosing the best route in the routing table. What is the longest matching prefix concept that we use, and some other advanced topics like policy-based routing, VRF Lite. VRF is a concept that we are going to use in MPLS. But if you use VRF without MPLS, that is called VRF Lite. And we will understand what exactly is VRF, why do we need it, and again, how to configure it. So we will learn the details of these protocols. We will have multiple labs on EIGRP, OSPF, and BGP. BGP, we are going to do a deep dive, and we will have a lot of practicals there. And we'll see some advanced topics like authentication, summarization, route filtering, path attributes, and all these things. How do they work? Some other advanced topics like BFD. We are also going to understand how BFD can actually expedite the neighbor failure detection in any routing protocol. That is something we are going to understand as well. So, of course, in every routing protocol, we are going to do a deep dive. We will understand it in three structure. First of all, the neighborship. So, very first thing router has to do, or routing protocol has to do, is to become neighbor with other routers running the same routing protocol. So, how does the neighborship work? What are the elements that affect the neighborship, and how can you troubleshoot if the neighborship is not coming up? And also, second phase would be the route exchange. So once you become neighbor, you need to exchange the information that you have with your neighbor and get the information from the neighbor, so that you can install it in your routing table. This is called control plane. Control plane means gathering the information about reachability. It's not actual reachability. You are not sending traffic to destinations. You are acquiring or gathering the information about possible destinations. That is called control plane. And the routing protocol, second step is to exchange this information once the neighborship is up. And third phase, we are going to talk about the advanced topics, as I mentioned, like metric tuning, authorization, summarization, route filtering, All these things we are going to understand in the phase 3 of routing protocol. Same thing we will repeat for OSPF. And we are also going to understand normal EIGRP and which is called the EIGRP classic mode, and also the EIGRP name mode, which is a new one supporting the address families IPv4 and IPv6. So you can configure everything under the same umbrella, and troubleshooting becomes easier if you use the EIGRP name mode. Same thing in OSPF, we also have version 2, which is what we use by default. And there is a new version called OSPF version 3 with the capabilities of IPv4 and IPv6 both, or the support for IPv4 and IPv6 both. So we will cover these things as well. And then comes the BGP. Of course, BGP will understand both type of neighborship, iBGP versus eBGP. What is the difference between these two neighbor types? Like, what is the difference, or how does the router behave if it has an internal BGP neighbor versus an external BGP neighbor? The core differences between them. We are also going to understand the path selection. So in BGP, the path selection doesn't depend on a single numerical value, which we call metric. Instead, it uses a list of 11 parameters, which are called path attributes. So how exactly we use these 11 path attributes in a particular order, and how does it help BGP to find the best path, basically, right? Find the best route to go from point A to point B. So once the routing protocol is done, then we are going to talk about the route policies, like route map. Route map, something that you can use. It's a very powerful tool for creating policies where you can match some criteria, and based on that criteria, you can take some actions. So we will see how route maps can be used in all routing protocols. And the biggest use case would be in BGP for the path attribute manipulation. We'll see how we can use that. We'll see some advanced topics in BGP also, like route reflectors and how does the summarization work, aggregation, and how the AS set feature and all these features work within BGP. So don't worry, anything that you don't understand here or you haven't done it before, we are going to cover it from the scratch. So we will make sure it is clear. For example, regular expressions, very important part for route filtering, and we are going to cover that also in depth. Then we'll cover some advanced topics. So once your switching is configured, your routing is configured, your infrastructure is ready. And then once the infrastructure is ready, means you have reachability from everywhere to everywhere else, you can start configuring advanced topics which needs the reachability to be already there. Like multicasting can be configured if your unicast configuration is already working. So we'll learn multicasting or one-to-many configuration, how routed multicasting happens or multicast routing happens, and how do we use the PIM protocol, protocol independent multicast, how IGMP is used in multicasting. And remember, for all these topics, we will have multiple labs also, so that whatever we are learning, we can also practice and see it in action, basically, right? And after this, we start the SDN, or software defined networking, or SDI, it is called software defined infrastructure, where you can do it toward the LAN side or campus side, which is called SDA, or you can configure it toward the WAN side, which is called SD-WAN. So we'll cover all the important aspects, how exactly it works, how the decoupling of control plane and data plane works. So control plane means exchanging the routes, exchanging the information about reachability, and creating policies that will be actually done on a central device called the controller. And the controller will be managed from a central device, which is called a manager. For example, in SD-WAN, we use vManage, which is a single pane of glass to see everything, to control everything. But the controller itself is called vSmart, which will be creating policies and pushing to the devices. And how do they trust each other, or how do they trust to the devices, the end devices? So the orchestrator is called vBond, that is going to enable trusting between them or enable communication between all these devices, right? So we are going to learn all these things. Similarly, in SDA, the orchestrator and the manager is called DNS center, Cisco DNS center or Cisco DNAC. So how exactly does it work? We are going to understand the logic here for that as well. Apart from this, we come to the transport technology, which are part of routing and switching, I would say. The tunneling technology. We'll see how exactly the GRE tunnels work, how MPLS work, multi-protocol level switching. It's the VPN technology, also layer 3 and layer 2 VPN. But in CCIE routing and switching or enterprise infrastructure, we only have L3 VPN, so L3 VPN application of MPLS. So we'll learn that, how exactly we can configure it. And then we will switch to DMVPN, dynamic multi-point VPN. which is a very interesting concept where you can use internet as your service provider and connect your branches. Like maybe you have a head office or headquarter in London, and then you have few branches, one in LA, one in let's say Dallas, Texas, one in New York City. Few branches you have in Europe and few branches in Asia Pacific, and you want to connect all of these branches over internet. So you can actually create a VPN over internet, which is called dynamic multi-point VPN, which is secured thanks to the IPsec or IP security, and it is completely dynamic thanks to the protocol called NHRP, Next Hop Resolution Protocol. So how exactly we can configure this setup and how does it work? We are going to understand, not only understand, but we'll also have a lab, actually multiple labs on DMVPN. So we make sure that we understand this logic completely. If you're wondering what is the difference between MPLS and DMVPN, we will understand that as well, because both are solving the same problem. You want to connect your branches to each other uh, over a network which you do not own. That is called the VPN technology. But in MPLS, the difference is that service provider is heavily involved. The service provider will be configuring the complete MPLS solution and providing the connectivity to the customer. So 99% work goes in the service provider network. DMVPN, on the other hand, has no involvement from your service provider other than providing you the reachability. That's why I said you can use internet, because as long as you can ping a public IP address from LA branch to a public IP address into, let's say, Paris branch, you will be able to form a DMVPN tunnel also without involving any service provider, because the service provider in this case is the internet service provider. They only provide reachability to internet. They don't provide any other services. So that's the main difference you will see between these two. Of course, because of this, MPLS is extremely expensive and DMVPN is much more cheaper comparing to MPLS. So that's why you see in SD-WAN, they can utilize all different types of connections, not only MPLS, but you can also have lease lines, you can have DMVPN connections, you can have even 4G and 5G type of connections, which we call LTE connections. And you can utilize all these WAN links effectively. That is what we call software-defined WAN. Then comes some infrastructure security services, like how do we configure AAA authentication, authorization, and accounting in your network? What is control plane policing and control plane protection? Some of the network security like access control list, storm control, DHCP snooping, all these topics we will again understand in structure of what is this, why do we need this, and how do we configure it, right? For example, port security. What is this? Port security is the method of securing your switch ports from any unauthorized access. Why do we need this? Because your switch is generally connected to end devices like computers, printers, servers. Somebody may easily disconnect their computer and connect a malicious device or a device which is trying to hack your network. So what will happen in that case is the source MAC address will change, right? Because now the computer is no longer connected. Instead, you are connecting another device, which is a different MAC address. So the port security can easily detect that and block the port so that the attack can no longer happen or cannot proceed from that point. So you can see, we understand what is port security and why do we need this. Then when it comes to configuration, it will become very easy to understand, okay, that's why we are doing what we are doing. So just to give you an example, right? Same thing we'll do with IPv6. Some of the IPv6 security features, including ACL and route advertisement guard, DHCP guard, binding tables, neighbor discovery inspection, and snooping. All these things are very interesting concept that we are going to cover here as well. Then we come to the system management, which is using how to connect to the device using console or using telnet or secure shell, which is called VTY lines. How do you connect using secure shell or secure copy? And netconf and resconf are the protocols used in programmability to configure your device from a remote location. So we will understand those things as well. SNMP logging, these are used for the network management and to see what happened at what time did it happen, like what is the timestamp. So logging becomes very important topic as well. Quality of service is very important, and that's a big part of exam as well. So many times when you configure your network and once the reachability is achieved between different points, different locations, you will think, okay, our work is done here as a network administrator, because now you can reach from point A to point B. But what happens is that people might start complaining that, hey, although I am able to go to from point A to point B, but my voice traffic is lagging. I can, whenever I make a phone call between Paris and LA locations, or within Paris, maybe between two different departments, I can actually experience some lag into the voice, or sometimes the voice is breaking, or maybe I'm transferring a FTP, I'm transferring a huge file using FTP, and it is taking a lot of time. Sometimes the connection is breaking in the middle. So you have to start looking at your network with from the point of view of the bandwidth. So you have a resource which is called bandwidth, and you have the limited resource there. And so many applications are trying to use that bandwidth. So you need to start rationing between them. You need to allow some applications to use it more comparing to some other applications. So this is generally called the managed bandwidth control, or bandwidth access, and it is actually managed unfairness. You are being unfair to some applications which are not so important, so that other applications can get a better treatment, like voice and video, which are delay sensitive. They should get the best treatment on the expense of the traffic which is going to LinkedIn, Facebook, or YouTube, which is not so important, right? So that is something called quality of service that we are going to learn. Network services are the services which you configure after your infrastructure is already ready. Means you already have reachability, but now you need to improve it. For example, you want to provide some backup for your gateways. So we will use some first of redundancy protocols. Like if you have multiple gateways, how we can use them and switch between them whenever there is a failure. NTP or PTP for the time synchronization, DHCP to assign IP addressing and IP configuration to the devices for IP version 4 and IP version 6. Network address translation, so that your internal devices from your organization can access internet without having a public IP address. So it actually translates private IP addresses to public IP addresses and vice versa. So what are the different types of net available and how we can configure them? IPSLA is network optimization. So you can check the reachability of services if they are up or not. And if the service goes down, you might want to change the path if a particular path is no longer available. So you can use IPSLA for that. Tracking and NetFlow also can tell you exactly what applications are being used in your network and which are actually consuming more bandwidth than the other, and at what times. You can get a sense of your network using NetFlow or flexible NetFlow, which is the advanced version of NetFlow. Some of the network operations, things like span, RSpan, this is actually part of the switching, and ERSpan, packet capturing, and some troubleshooting tools like what exactly we can use, conditional debugging and packet tracing. All these things we can learn into the troubleshooting part of the network, right? Then comes the last part, which is the automation and programmability. So as I was mentioning, that to start configuring your devices from a remote location, you need to send your instructions in a particular format, which is called the data format. And generally the devices can be configured in the JSON format, JavaScript object notation, or XML, YAML, or you can use something called Jinja. So these are different encoding formats so that you can send the instructions to the device. What language do you use? That is called the modeling language, and we will learn the Yang data models for that. Exactly what do they mean and how we can use them. And then comes the scripting. So as I mentioned, embedded event management. I was mentioning earlier, if somebody tries to delete BGP on the router, it should be ignored, and that should be logged. And the user who tried to do it, that information along with the timestamp should be logged. So all these things you can do with the EEM, and you can also do it with the Python. So in the Python, there is a one very interesting concept called guest shell. What is guest shell? So every Cisco iOS XE routers, the newer iOS, which is called XE, those routers like CSR routers, they actually have a full-fledged Linux operating system running inside them. I mean, not running, but you can spin it up, which is called actually a guest shell environment, which is called a Linux environment. And inside the Linux, you can execute Python script, which can interact with the router and actually take some actions on the router. So you can actually leverage all the power of Python from within your router. You don't need a computer to create Python scripts and execute it from there. You can do it right from inside the router. by spinning up a container, which is called a Linux container, and then running Python inside that Linux container. That's called get shell. And we are going to see the practical for this as. And guess what? We can also combine EM with the Python. So anytime something happens in your router, a particular event happens, you can run an EM script. But instead of taking some actions within the EM script, the action would be to call a Python script or to execute a Python script. So anytime something happens, you can execute a Python script as a response, and the Python script can have much more detailed uh, actions configured, right? So in the programmability part, we will also see that how we can use RESTconf and netconf to send instructions to the routers. And for example, RESTconf can use either the CLI tool called curl, CURL, or you can use a GUI tool called Postman to send your RESTconf APIs to your router to either retrieve information or to change information, and how we can monitor and configure these things. So we will see all these examples as well. We're using netconf, RESTconf for gRPC or Google RPC, which is the Google's transport protocol, just like netconf and RESTconf. So you can see that we have the switching, the routing, VPN technologies, some network services, SDN, and programmability. These are the main topics that are going to be covered in this course. So that brings us to the course structure itself. What exactly can you expect from this course? So many times you will see the other courses that like when we were creating this zero to lab course, we were checking the market, and we saw that there are so many bootcamp style courses out there. Means you have 5 days CCI course, 10 days CCI course. So you actually go through all the things which I just mentioned in the syllabus within 5 days, uh, 8 to 10 hours classes every day, and there is so much content that the instructor is explaining you the things, showing you the practicals, that you hardly get any time to do it on your own. And by the time 5 days are finished or 7 days are finished, you are done with all the topics. And now you are left with just practicing, and you have a mammoth work in front of you to go through everything again. And the course is already finished. So we thought, okay, that's not how it works. We need to create something where you can build upon your knowledge slowly, steadily, and become more and more confident into every single topic that we just discussed. So that's why this course structured in a way that we have the live Zoom session that we are having today, like this one, once per week, and it is going to be 2 hours per session. So although it is saying 2 hours, but this course is not time driven; it's topic driven, right? So basically, or technology driven. So we are going to cover one technology per session. Like if I am taking up DMVPN, or if I am taking up quality of service, I'm going to talk about it, and I'm going to do a lab on this. I'm going to explain you in depth theory, fundamentals, and then followed by a lab. So sometimes it takes more than 2 hours as well. But then there will be some topics like Ether channel or something which is not so big. It might end up even before 2 hours as well. So 2 hours is just a reference point, but generally the class time could be less or more depending on the topic. It's a topic driven class, not the time driven class. So in this, I will start the session with the theory. So let's say I'm starting today. Let's talk about EIGRP. So I'm going to explain you EIGRP in detail, how exactly it works. Again, what, why, and how. So first hour will be the instructor-led topic discussion. And again, this is just a reference. It could take less or more than 1 hour. But then it will be followed by a lab on the same topic, which will be done by me. So I'll be configuring everything in front of you. Whatever we learn into the first theory part, we are going to implement this into the lab right there. So whatever you learn, you see that implemented also, which strengthen your understanding of the topic. And since I'm doing it, I will not be doing it quietly. I will be explaining every single point, what I'm doing and why I'm doing it the way I'm doing, so that all your doubts will be cleared exactly what needs to be done and how it needs to be done, right? So after it is done, after the live session is done, I'm going to send you the same lab along with the solution file on your email. So when I send you this information, you will be able to do this lab, and you will have the whole week to actually practice it as many times as you want to become comfortable with the topic. Of course, if any issue uh, occurs, like if you're doing it and you don't understand something or you get stuck, please refer to the solution file, because remember, we are not testing you. When I send you a lab after the class, it's not a test. You are still into the learning mode. So when you are doing it and you get stuck, you have to be happy. Okay, now I'm going to check the solution file and I'm going to learn something so that next time I don't get stuck at this point. And when you do it continuously again and again and again like this, in the exam, you will not get stuck because you will have all the necessary knowledge that you need, right? But of course, sometimes even the solution file is not clear. You try to see the solution and you say why it is done the way it is done in this solution file. So you can definitely ask me for the answer. So how do you get in touch with me? So in every live Zoom session, at the end of the session, we will have a Q&A session where you can ask me any questions if they are small questions. But if you have a detailed question, like you need to show me some screenshots and you see that this is the solution I'm getting, why is it like this? We have a Facebook group created. So definitely join the Facebook group so that you can ask questions there with the detailed screenshot and everything you can send there, and I will be answering there. The benefit of that Facebook group is that if you are posting a question, there are many other students also who have done CCI already, or they are really having a long experience into routing and switching or enterprise infrastructure. So they might also be able to answer you even before I answer, or vice versa. Maybe they were also thinking on the similar lines, and when they see your question and my answer, it will actually clear their doubts as well, or maybe they can also add something to it and they see. So it's a great community. Definitely join that group to ask any questions during the off time. So if we are not having a live session, that time you can ask the questions there. Also, remember that whatever we are covering, the topics you can also revision online, because the one of the class recording from the previous class is available online, and it will be actually available to you for lifetime. I am saying one of the previous class means it is the exactly same class like we are going, same topics. So if I'm teaching EIGRP, you can get the same EIGRP information in that video. But the good news is that you will have access to it for lifetime. So you can watch it again if you miss something in the live class, or if you could not join the live class, you can definitely refer to the topic of that week online. And you will see there is a comment section below every recording where also you can type your question and send it. That also comes directly to me, and I will be responding to you on that question, right? So that's why I was saying how this program can help you is the main thing missing is a lot of practice in many programs. Either it is too much practice like boot camps, or it's just a video course online where you have to arrange your own devices, arrange your own topologies and do it on your own. And then if you have a question, there is no one else there to answer. So we wanted to get rid of all these issues. That's why this course is spaced out. This course has all the necessary theory that you need. You will be provided with the OVA, and the OVA that I already sent you, that will have all the information that you need to import it into the VMware, and you will have the working topologies right from the beginning. So you don't need to do anything else. You can directly concentrate on the topics, and you have a instructor support throughout. So you will have my support anytime you have a question. You know there is someone I can ask and get some answers. Right. So in this course, you will get all the single protocol labs. Single protocol means when we talk about a single topic, like today is EIGRP, or next few sections will be EIGRP, then we will start OSPF, then it will be BGP. So these are single protocols, and there will be labs every week concentrating on that particular protocol. So these are called single protocol labs, right? Along with the solution file and the Q&A session. We also cover all the advanced topics, SD and SDA, and programmability and automation. Also, once we will be done with all the single protocol labs, means all the topics are covered, we are also going to do a full actual exam like multi-protocol lab to practice. Now, what do we mean by multi-protocol lab? Multi-protocol lab simply means that there will be a single topology where we will be configuring all the, or not, if not all, most of the protocols that we have learned, most of the technology that we have learned, starting from layer 2, building up to layer 3, VPN technologies, SDN, and programmability. So this will be just like an exam, like when you go for the exam and when you come to the deploy and operate part, you will see the similar topology and you will see the similar questions there as well, right? So you will know that how to tackle them by practicing this multi-protocol lab. So here you don't need to learn anything new because it is built upon your knowledge of the single protocol labs, but you just need to configure everything at the same time. It's not just OSPF, not just BGP, not just QoS. It is everything in the same lab, right? And of course, I will be giving you time to time troubleshooting tips. But as I mentioned, if your fundamentals are clear, you are already good at troubleshooting. So that I cannot emphasize that enough to make sure that your fundamentals are very strong. And don't worry, that's why we are here. We will make sure that your fundamentals become very strong. And you will have my support throughout the course duration for a live Zoom session Q&A or any question that you ask on the Facebook group or below the recordings comment section. And cherry on top, you will have lifetime access to class recordings from one of the previous classes, not this class, because they are exactly same classes, same topics. But yes, all the topics will be there that we are going to cover for CCIE. So the good news one about this is that in case if there is an update in the exam and we have to add some new topics into the exam, we are going to add those to the recordings as well. So even if you're checking out the recording after 2 years, you will get the latest information that you would need to pass the CCIE exam, right? Tools that we use for this course. So we are going to use EVNG on VMware. So VMware is a hypervisor software, and this software allows you to create virtual machines. And one of the virtual machines that we are going to import in this VMware is called EVNG. So EVNG is the name of the virtual machine, and EVNG is a simulator. EVNG is an emulator, not a simulator. So simulator basically means that you are simulating the routers and switches as if you are dealing with the router or switches. So they are actually softwares behaving just like operating system of the router or switch, but they are not actual operating system. So you don't get all the features in a simulator. But EVNG is an emulator, means it doesn't try to mimic the real operating system. It actually has the real operating system. Means we need to upload the real operating system IOSs from routers and switches uh, and SD-WAN devices into the EVNG, and EVNG is just providing you the front end. In the back end, it is actually using the real operating system of the networking devices. So you get the complete support and complete command set that you would get in the real device. The only thing missing is the physical hardware, right? But if you want to do EVNG on your own, you can do it. It's a free software. You can go to evng.net. But the issue is it's just a shell, right? When you download EVNG, it's just a Linux operating system. You need to somehow procure the iOS images for routers, switches, SD-WAN devices, and then you have to copy them into the Linux, and you need to know a little bit of Linux also to license these files. You need to have the proper licensing information for every routing and switching devices. And once you are done with this, then you can open the browser, open the EVNG, and then you will see there are no topologies by default. So you have to start creating topologies, and you have to think, okay, for DMVPN, what topology would be good? For MPLS, what topology can I create so that I can practice everything? So you can see there will be a lot of work before you can start learning things and start practicing what is important. So we here in Karotul wanted to get rid of all these issues for the students. We wanted you to directly concentrate on learning the important stuff for CCIE right from day one. That's why I created an OVA package, which includes the EVNG. I have already copied all the iOS images or the SD-WAN images into the EVNG. I have already licensed them that need to be licensed, and we already have created topologies for you so that we can directly start configuring things. And IP addressing is also already done. So when you start when you import the OVA that I sent you in VMware, you will see that there will be already some topologies. Like most of the time, we'll be using the base lab for routing and some STP and EtherNet labs for switching. So these labs already have, or these topologies already have the devices connected to each other, and some basic configuration is already done. So you can start the devices and directly jump into the lab configuration without wasting any time to set it up for you. So that is something is already done for you. So topologies are already set in EVNG. Labs files that I will send you, you're actually going to do it based on the topology of EVNG, and you can check the solution file in case if you have any issues. And that's what I was mentioning earlier. During the off days in a week, you are encouraged to do the labs again, and feel free to get in touch with me if you have any questions using the Facebook group or the comment section under the recording. The EVNG software itself, it actually is a Linux container, but I have created the OVA, so you just need to import it into the VMware. So the OVA file that I sent you already, you will see that in the same email, I also have a Dropbox link to install VMware. So in case if you have any issue in downloading VMware, you can actually use that link to download and install VMware, and then you can import the OVA. So during the week, anytime you have any issue with the OVA setup, you can actually go to the recordings again. You can go to the portal 02it.com or mykajabi.karotul. There you will see the very first video of the first week of CCIE or Zero to Lab is the EVNG setup video. So you can watch that video and you will get all your questions: how to import the OVA, how to start it for the first time, how to access the topologies, how to start the router, save the configuration, wipe the configuration, stop the routers, shut down the EVNG. All the questions can be answered in that video. So highly recommended. Download the OVA, watch the video, set it up, and in case if you get any question even after that, or if you face any issues, then shoot me an email. You can reply to the email I sent you, and we can take it from there. We can fix it. Don't worry, because next week the first session would be subnetting, and although subnetting is not directly asked into the question, but you will see it is prevalent everywhere in all the diagrams. So it is very imperative to understand how subnetting is done, right? So that's why the first session will be a theory session only. So don't worry, you have this week and the next week also to make sure your EVNG is properly working before we get to the configuration part, right? How much RAM should you have in your laptop or your desktop? So for the routing and switching part, I would say 8 gig would be enough. But for SD-WAN part, you need at least 16 to 32 gig RAM. So generally, what I recommend students is that if you are investing in CCIE, you are not only investing your money but also investing a huge chunk of time. Of course, the benefits are huge if you really acquire all the knowledge that you need for CCIE and you get the number as well. But you should also consider spending a little bit money into like a second-hand desktop PC or a laptop which has more RAM, like 32 to 64 gig RAM. If you go to like eBay or Amazon, there are tons of second-hand CPUs, and you don't need the latest processor or anything. 8th, 9th generation i5, i7 is more than enough. And if you put in 64 gig of RAM or 32 gig of RAM, it will be like 200 or $300 something, which you can do maybe after 5 or 6 months from now, before we start SD-WAN. So you do have time. You can save some money and maybe consider buying a dedicated PC just for CCIE. For the time being, when we start switching and routing, whatever the laptop you're using right now or desktop you're using right now with 8 gig of RAM or 16 gig of RAM will be more than sufficient. So don't worry about it right now, but it would be a good investment maybe in few months. And that way you don't need to worry about uh, resources when it comes to very, very advanced topics, right? So the OVA that I sent you, you need to import it into the EVNG and you need to set the RAM according to how much RAM you have. And also the network should be set to net. So when you go to the settings of your EVNG, which you imported, you will see that there is a network adapter part, and that must be set to net so that you can get an IP address to open that in the browser to start using EVNG. Again, this information you can find into the first video, into the recordings. And also when we start the labs, I will also explain you how to open EVNG and open the browser when we start the lab configuration, right? And you can see memory, you can set according to how much you have. Like I have 128 gig in my PC, so I have set it to 32 gig for most of the practicals. It is more than sufficient, right? So that's it from my side. I just wanted to introduce you to the program. What exactly are we going to cover? How exactly we are going to cover? And what is the structure of the program? So the next thing is what is expected from your side. So all you need to do is one thing you will notice is that whenever you want to learn something and you want to become comfortable in something, you need to be consistent. So just show up into the live sessions because they just keep your momentum going on, and do the labs as I send you, and ask any questions that you have and be consistent. So when you just do these things, everything else is taken care by us. You don't need to worry about procuring any images or creating topologies or referring to any other material. This will be more than sufficient for you to gain a massive knowledge in your CCI journey. You will become much more confident into all the important protocols. That is our guarantee. About myself a little bit. So I have more than 18 years of networking training experience. And I have 2 CCIs, routing, switching, and service provider. And for last 11 years, uh, I have trained numerous CCIE candidates and more than 60 to 70 CCIE passing uh, candidates as well. What happens is so many people don't even take the exam because it's a long journey. Some people take it and it's such a difficult exam that even if you are prepared, it's not guaranteed that you are going to pass, because that the performance on that day depends a lot, right? It matters a lot. But I get so many emails from my students who didn't even take the exam. They just took the written exam and they said, okay, I got a great upgrade in my job. I got a new job because of the massive knowledge and the confidence that I gained from the class. So I can only imagine if I pass the exam, what next level I can go to. So you can see the journey is very important. Of course, the destination is the CCI number. We want to make sure we get the CCI, but journey is equally, if not more, important. So I have 2 CCIs. I did it. First one I did in routing and switching, and then I did in service provider. A third one might be something coming up soon, maybe in a couple of years, depending on how much time I have with all the trainings. But yeah, mostly routing and switching and service provider, because both deal in depth with the networking technologies. I also have a lot of practical experience because I perform consultation work, means I provide consultancy to different organizations, mostly service providers. So in this work, I just try to fix their network. So they actually show me their designs and their network configurations for a particular part of it, and I actually provide them the solutions which can improve the network. So whatever the latest technology being used in service providers or in the networks, enterprise networks currently, I am aware of those things. Well, not all of them, but most of them. Nobody works on everything. But whatever I learn new, I try to incorporate into the training as well, so that we can benefit from that information. So having said that, let's get started. Thanks a lot, guys. And today was a small session. Just wanted to introduce the things. So make sure this week you set up the OVA, and you do have next week also, because we'll do submitting next week. But yeah, any questions, feel free to get in touch with me. So thanks, Demon, Kelvin, Robert, and let me know if you have any questions.
Thanks, Afik.
Thanks, Kelvin. Thanks, Demon.
Thanks, Afik.
Thanks, Robert. So I'll see you guys next week, and have a good night. Bye-bye.
Good night. Bye.